Okay, in this example of floating point arithmetic, we're again going to be converting a number with a 10-bit mantissa and a 6-bit exponent to decimal, but this one is slightly different to the previous example. And that's because if I interrogate the sign bit just here on the most significant bit part, the left-hand side, then I discover that the sign equals 1. And that means that the number we end up with is going to be a negative number. Alright? So, what I'm actually going to get is minus 1. And then what I'm going to have to do is add all the other numbers after the binary point. Remember, the binary point goes after the sign bit. So, first fraction I come to is this one. It's got a 1 there, so that's a half, so we're going to add that in. The next number, it's got a 1, so let's double the denominator, remember, will be a quarter. That position is a quarter. The next one, third one along, is a 1 again, so double a quarter, what do we get? We get an eighth. Let's go to the next one. That's got a 1 in it, so double an eighth, becomes a 16th. Next one's got a 1, so we double a 16th, and that's 1 over 32. Next one's got a 1 there, so double that, the 1 over 64. But the next one has got a 0, so we don't need a fraction for that one. We miss it out. We go to the next one. So that fraction is not going to be 1 over 128. It'll be 1 over 256, because that will be double 128. The last one we don't need because there's a 0 there. Now if I was to add all of those numbers together, including the minus 1, don't forget, I would get this number, minus 0.01172. And that's my mantissa done. Alright? So let's just make a note of that to the examiner. That is my mantissa, and I've shown my working out. Let's look at the exponent now. The exponent, again, it's got 6 bits. What does it equal? Well, there's only 2 1s here, and we know that that's weighting is a 1, and this weighting here is 2, and 2 add 1 equals 3. So the exponent value is 3. So we need to write down a final solution to the problem, and the solution is generated by doing this. We've got minus 0.01172, and we're going to multiply it by 2, remember, because of the binary system, and this time to the power of the exponent, and the exponent this time is 3. Well, that's equivalent to minus 0.01172 times 2 times 2 times 2 is 8. So the final answer is minus 0.09375. So watch out if you get a question that is negative, right? You have to spot that the sign bit is 1, and if the sign bit is 1, then you start off, when you add your fractions, you must not forget to add minus 1 to your answer. And then it's the same as other floating point arithmetic questions that are positive numbers.